Hi, my name is Bruce Wallace, Director of Product Management at Nokia. Today we're going to discuss building for openness with Nokia Service Router Linux, specifically the gaps in model-driven management and what we as an industry are missing. Whilst data center networks and their building blocks have evolved heavily over time to keep pace with growing infrastructure demands, the management plane and overall management architecture has been relatively late to the party. With the massive scale requirements of web-scale companies leading the way, our industry has been under a paradigm shift in the way we design, implement, and operate data center networks. Let's start with a look at how our management architecture has transitioned over time. Although slower than I'm sure we'd all like, the days of SNMP and CLI tech scraping are numbered. They're simply not granular nor scalable enough to achieve true certainty of the network state at any given time. The SNMP polling architecture by definition implies that the decisions an operator or controller makes are based on old and potentially irrelevant data. Not only from an end-user standpoint, the unnecessary overhead and complexity these interfaces add to controllers and automation frameworks is undesirable, to say the least. If we as an industry were to embrace an intent-based future, we needed something new. As a reaction to this, a slew of proprietary APIs appeared. These introduced integration and interop dependencies, getting us even further away from an open, extensible ecosystem. We knew better as an industry, of course, and the IETF-backed NetConf and RESTConf initiatives appeared. Vendors were forced to pivot their management architecture to support a brand new model-driven world. To their credit, these interfaces supported the first wave of automation, that of configuring a device. This led to overall efficiencies in the way we drove our networks in the wake of consistent traffic growth. These innovations did not penetrate deeper than the interface level, however, and internal schemas and the infrastructure they were contained in were still left mostly untouched and non-extensible. As we all know, the networking industry is no stranger to new interfaces. The way we've typically structured data within devices involves one or many internal schemas that are inaccessible and mostly unchanging to the majority of the system. As we go up the layers, every time there is an abstraction or translation done between these and other data structures, there is a chance that information is lost in translation, unscalable to retrieve at volume or high frequency, or needs to be manipulated in some way. Unfortunately, the quick way to pivot to the new model-driven world was to introduce another one of these translations, translating models to internal schemas, or placing them on top of SNMP, and manipulating data as necessary. This performance and visibility tax is only exacerbated when you take into account the independent schemas of previous northbound interfaces. With some data structures being harder or impossible to translate, this led to a subset of varied visibility depending on the interface chosen, requiring implementing multiple northbound interfaces to simply achieve wide enough coverage. All in all, the solution resulted in less than SNMP-like visibility, albeit over modern interfaces. With the necessity of more and more data to make accurate decisions at scale, this tax was inevitably untenable. How could we ever hope to successfully represent an ever-changing network with an unchanging schema? It is for this reason that we as an industry needed to prioritize evolution and extensibility as first-class features. We've been taught in the past that the need to change indicates shallow or non-future-looking architectures, and that the best live forever, immovable and unbending. Evolution, however, isn't bad, and an architecture's ability to embrace change over time right to its core is a hugely beneficial characteristic, especially in today's era of networking. If the past to date was to tell us anything, it's that innovations will always drive change, and the network's ability to keep pace with that change in a reliable, extensible, and scalable manner has never been more important. This made the vision clear. Building from the ground up to support reliable and scalable visibility and configuration was needed, with the core design principles being openness of infrastructure, extensibility, and the adoption of emerging technologies to support reliability and scalability. Given a blank sheet, rather than build in a closed manner, why not open up the infrastructure itself? There has been a clear and ever-growing demand for this from operators. give applications the ability to simplify their own internal schemas around data modeling languages, and then expose these schemas directly for consumption by northbound interfaces. Any object, any interface. This provides deep visibility right into the heart of system state, and allows northbound applications to make API choices based on their functional requirements, rather than the data they need visibility to. Enter a true re-architecture around model-driven management and modern interfaces for its consumption, packaged as Nokia's SR Linux network operating system. An extensible and performant infrastructure to allow applications to define and declare their own schemas, allowing the retrieval of fine-grained system state, setting of configuration, and a scalable interface to support more granular data with push-based streaming. SR Linux was built from the heart with an open, scalable telemetry framework in mind, where the system and applications themselves speak the same transport and message declaration mechanisms as used in the northbound interfaces, gRPC and protocol buffers. This further optimizes costly serialization and deserialization, whether it be to a Nokia-written application or an operator-written one. Building SR Linux in this manner, or building for open as we call it, meant making conscious decisions throughout development to build in an open, extensible, and most importantly, consumable manner. We've coined the term unified open management to describe this architecture. Visibility, however, is only half the battle. Without an extensible and reliable platform, your ability to provide action to insight is limited. The classic model of providing this action is to use vendor-defined APIs with vendor-defined structures underneath. Whilst this model has served us fairly well in the past, it provides no ability for an operator to react to their customers and internally develop and deploy solutions to meet their demands. In a world where extensibility is a mandatory requirement, the openness of the architecture is paramount, and the idea that systems can only be extended by the vendors that build them is a broken one. Opening up the stack results in the ability for the architecture to embrace future requirements, with the operators now able to integrate their applications at every level of the management stack. This allows networking teams to embrace DevOps-style mentalities in order to provide an outcome from the analytics. The mantra is simple: be more agile, merge changes more frequently, automate build and testing pipelines, and deploy. This simple philosophy, when coupled with the SR Linux's modular and open system architecture, allows the deployment of workflows or applications directly on the network, consuming previously idle CPU cycles, drawing insights locally, and performing actions immediately. All of this powered by an architecture purpose-built for model-driven management. This, however, only covers the management aspects of applications. After being integrated, these applications need the ability to drive the network in an extensible and performant manner, which brings us to the final piece of the puzzle. SR Linux offers an unrivaled development environment for network applications, with a wide array of programming languages available via protocol buffers, or protobufs, transported via gRPC. Protobufs, when used with gRPC, allow local and remote integrations, reliable request-response messaging, and backwards compatibility. This level of decoupling promotes innovation in the network, allowing operators the flexibility to react to customer demands without lengthy feature requests into their vendor. With a simple set of gRPC services exposed in the form of the SR Linux NetOps Development Kit, or NDK, operators are able to perform automated tasks across a wide spectrum of complexity, as simple as reacting to an event and making a configuration change, or as complex as implementing their own routing protocol. All of this and more is supported via the NDK. With us now able to identify issues in the network and react to them immediately via native agents, to fully close the loop on an intent-capable network, the architecture must support visibility into the agents themselves. A truly open model-driven architecture allows operational visibility to finally extend to these applications, allowing them to deliver a Yang model of their own, have this integrated into the system, and drive configuration and state using SR Linux's infrastructure. This allows operator-written applications to immediately support transactional configuration, checkpoints, but most importantly, streaming telemetry. Applications developed against the SR Linux architecture can be operationalized, monitored, configured, and debugged the same as any other Nokia written application, with standard open interfaces. More importantly, this allows developers to truly teach the network their language, rather than being forced to learn its. In the past, network operating systems were closed proprietary systems. This served the industry well in a time where most hardware platforms were also closed proprietary systems. Open APIs, for example GNMI or RESTconf, have shown the demand for openness from vendors, but they miss the fact that open APIs into a black box only remove one layer of the onion. True openness can only be accomplished at the heart of an architecture. SR Linux provides more than a network operating system with open APIs. It provides a development foundation for network operators and architects to automate workflows, simplify operations, even write their own control plane. This truly shows the strength of a modern architecture, where the infrastructure itself is exposed for extensibility. My name is Bruce Wallace, Director of Product Management at Nokia. For more information on our Nokia Data Center Fabric solution, please follow us here. Thanks for your time.